try another example. Remember how we drew this grid of frogs a while ago? The code for that looked like this. As you can see, it was pretty massive. An obvious building block for this is the drawing of the frog face. Let's try to write a function for that. It will have to take in the parameter describing the initial x and y position of the center of the frog's left eye, as well as the number I, which represents the number of the frog. The I argument helped us to determine the shade of green we were drawing the frog in. Let's define the function to draw the frog face. First, we have its return type, void again, then its name, frog face, then the arguments, which in this case are x, y, and the count. We will then call the function inside the for loop like this. One thing that we have to be careful about is modifying the arguments of a function. In processing, any modification to the function arguments that happens inside the function are not kept once the function finishes execution. The simplest way to see this is to change the frog face drawing code to look like this. The difference here is that we are changing x inside the frog face function instead of in the for loop. If we do this, we will always have only one frog face appear on the screen because the x value does not change. Thus, even if the function is called 5 times, which it is called with the same arguments. Another way to see this is by using text statements to print out the values of I and x at every loop iteration. When we modify the x value inside the frog face function, we can see that it does not change like this. The function body is called the function's workspace. Any change happening here to the values of the arguments is valid inside the function body, but it is not valid once the function finishes executing. Functions do not necessarily have to concern themselves just with drawing. We can define functions whenever we need a specific building block for our program. The rule of thumb of the decomposition of a program into functions is to identify any part of the program that is done multiple times and that we can reuse. That part is most likely a good candidate for a function. Let's say we have a program that needs to count the number of elements equal to 2 in an array and print them, and then needs to count the number of elements equal to 7 in the array and print them. We can define a function called count, which returns an integer, which is the number of times the value given as an argument, say x, appears in the array A given as argument. The function body will go through the array and increase a counter called number count every time the value x is encountered. The program would look something like this. We can call the function count anytime we want and with different arrays as well, as shown by this code, without any modifications of the function body. This is what a good decomposition will allow us to do. Let's look at a more difficult problem where we want to draw histograms whose height is proportional to the number of 1s and 2s found in an array. This problem decomposes itself easily into two main problems. One, counting the number of elements equal to 1 and 2 in the array. The other, drawing the histograms proportional to these counts. We will define two functions, one which is count, which we have already defined, and another one for drawing the histograms, like this. The function for the histogram will take in as arguments the histogram width and height, the bottom left corner of the histogram block, and values for the red, green, and blue of its color. The body of the function looks like this. Let's see how it all works. So remember, When you are thinking about using functions, think about the decomposition of the program. Identify the areas that are either the biggest or the most widely reused, and define the functions to implement them. Once you have defined the functions, include them in your draw method or your setup method, and run the code to see what happens.